Okay, well, last week I said I was going to be mounting my Milwaukee battery holders onto my robot, but I had to drill through some stainless steel sheeting. Well, after spending a half hour on one 9/64-inch hole with a brand new bit and still not being through it, I finally decided I'm giving up on trying to go through the stainless steel sheeting. And we'll mount it on the side. So if I can change cameras. Okay, let's see. I'm gonna have to turn off background. Okay, now I think I can get it. My camera is long enough. I had this hole right there, and that was after a half hour of drilling total in about 10 different times. So I've decided instead I'm going to mount it on the side here. I'll only be using 2 of those 3 holes, which I don't think should be too big a problem. But it gives me then the opportunity to still be able to get at the battery very easily and still have it connected to all of the power connections I need in there. So now I'll switch back to my other camera. And I did not get a lot done otherwise, this being tax season. So I still want to get those 2 mounted and wired up so that I have fused power for motors and so forth. Then I plan on getting the itsy bitsy wired up with for the motor controller and the voltage monitoring, and then the RS-232 communication to the Raspberry Pi, which will eventually get put on here. I still need to get ROS loaded onto both the Raspberry Pi and onto my laptop so I can get those 2 talking to each other. And that sounds pretty ambitious for this coming week. That's it.
The holes that were in your stainless steel, how did they originally get in there?
That was back probably about 6 years ago when before I had the piece mounted, and I was able to use my dad's drill press.
Yeah,
and had him helping, and he was used to working with the stainless steel sheet, so he knew all the tricks and had the right tools.
I had no idea it was so hard.
And another option would be just get a sheet of aluminum and remake that plate. And I don't know how many holes and stuff you got in it, but if it's going to be that much of a problem, you might be better off with, putting something else on there.
This is kind of the test bed anyway, so that might not be a bad idea.
I found out one time, if you pull bed frames out of the trash to use as angle iron, that those, I went through the same process. I was trying to drill a 1/2-inch hole through one, and I burned up like 4 or 5 drill bits. And I found in the back of the building, I found a drill bit sharpener, so I kept resharpening them, and finally got it drilled through. And then somebody said, "Oh, well, bed frames are hardened. They're not just standard mild steel." So, they look just like the stuff you buy at the hardware store, except they've hardened the thing. So it turns out I could drill like a 1/4 inch or up to a 3/8 inch hole. Seemed to work really well, but when I got up to 1/2 inch, it would not cut anymore, and I don't know why. So that's just more things that you learn over time.
Well, I did some research, and they said that stainless steel is not hardened, but it hardens very quickly if it's heated. And so people who use the old, okay, if it cuts okay at a slow speed, it'll cut even better at a fast speed. That's just more heat and causes the material to harden even more. So I've been going at very low speeds, but it doesn't seem to be cutting. And I've tried multiple bits, but I don't have my dad's tools or skills for sharpening bits properly for stainless steel. So that's that. Next.
Jeff, you want to go or you want me to go?
You can go.
Let's see, progress on my side. As a reminder, I've got this radio control, hand-built radio control unit, and it has a mode switch on it to signify whether or not I want manual control or whether I want what I'll just refer to as command velocity control. And so in my embedded code, I've got this tractor control. That's the code that runs on the microcontroller that sits on the tractor. And I've changed that a bit to, based on the value that the switch is providing to change the mode. So that's all relatively easy and simple. But then it came time to subscribe to command velocity and have the microcontroller actually talking to ROS. And that's, you could do it a couple of different ways probably. I could write an MQTT server or use ROS Serial, which is the ROS way. And I was trying to make the ROS way work, and I've never had so much trouble getting ROS Serial to work. So I've got, I've been spending time on these other programs just focused in on all I want to do is something simple, and getting that include statement recognized. I don't know, I must have messed up my libraries or something. But I finally got, a very simple program to work. So now I've got to translate that back into my main program. And this is where I'd mentioned while we were off the recording, there's a function called supposedly create timer in ROS, and it would just make the code a little bit cleaner. And I'm just going down a rabbit hole trying to make this work, because in this particular program, it just doesn't want to find that library, and it's throwing all sorts of errors about, hey, the timer isn't a part of the ROS package. So anyway, I might spend a little bit more time on that timer. I might rebuild a test laptop to try to figure out what I've done with my libraries, or I might just go back to what I consider to be the this standard way, the way that I've always known to control the loop, which is, just this sort of thing. This is in my main loop. So that's where I'm at, fighting with ROS Serial and my libraries and timers, and trying to get my tractor to subscribe to command velocity so I could take a steering and angle steering and throttle command. And everything I've done is out here on the embedded code. That's it.
So I said I had several things to talk about today. First, we'll start with the thing. A meeting or two ago, we were talking about displaying things on RVIZ, and Terry said, "Well, how can I display the width, the path coverage of the snowblower?" And I said I didn't know right offhand. So I went back and played with that a little bit, and it turns out, let's see, get this out of the way. Share the screen. Screen one. So it turns out if you come in here, let me try something here. Let me move this over to my other screen and stop sharing this screen and share screen two. And yeah, that's exactly what I wanted to have happen. So back over here where it belongs. This one over here. I think I might get a better display if I do this. So this is basically these red things getting left behind are 1 meter wide and 1/10 of a meter thick. And what these are actually the arrows from odometry. So if I'd go back, yeah, that's going to be real convenient. Let's say close that. That was under this one. So if we look here, and of course it's going to show us threads because that's what they want to do now. But if you zoom in on these and look at them, these are just the little arrows on odometry. You turn on odometry and it puts down at the rate that you tell it, it puts down an arrow to tell you where the base of the thing is where odometry is, and the angle is telling you what the heading is. So that's just a standard thing built into RVIZ. You can control that. And let's see, does that show up over here? And I don't have the parameters shown. It just says odom is turned on. So as you drive around, it leaves these arrows behind. So then I went in and played with the values on here. And over here on the left, you can see that under the shape of the arrows. So it's putting down arrows, and then under the shape of the arrow, I set first of all, I set the head and the shaft, or the head length and the head radius. So when you look at the arrow, it draws this like a cone on the end of it as the head. So you can control how long it is. So you can have long pointy arrows. In fact, here's a reference. Here's a reference arrow over here. You can see it's kind of a long pointy arrow, or you can make those short and fat if you want, and you can change the diameter of those. So I came in and I just said, I started off trying to make those wider, and they don't work because then the lighting, since it's a cone, the lighting makes them in the shadow the entire time. So what I did was I came over to the shaft, or the head length and the head radius. I set both of those down to 0.01 meters, which means I'm basically setting them down to a point where they're almost non-existent. If you zoom in enough on one of these things, you might be able to see a little thing sticking out there. But basically that was to get rid of the head of the arrow. And then they have the shaft length and the shaft radius. And on this one, the shaft radius is set to 1 meter, and that's what's controlling the width of this. Let's see, can I zoom in again? So setting the width of this thing is the 1 meter over here on the left, where I said the shaft radius is 1 meter. Because technically, if you rotate this around, those are actually big discs. It's not just a big wide bar like it looks like. So if I turn it to the side, those would be real nasty looking big round discs. But since this is a fairly quick and convenient way to do it, that's just I thought this was a reasonable way to go. And then the shaft length, the 0.1, controls how thick each one of those slices will be. So just by playing with those numbers, you can make it do all kinds of interesting things. And as you drive around, let's see how we get back. Oh, I thought I had it where it showed going up around the corner there. I guess I don't. This is all I have right here. But as you drive along,
Okay.
it plops these down as you drive forward. And what controls that is you look back over here and it says you have position tolerance and angle tolerance. So the position tolerance says if I've driven 1/10 of a meter, it's going to plop one of these down on the screen. So I can make that, I could spread that out to say 1 meter if I want a lot fewer ones on here, or I could set it even closer if I want that. So things you might want to do is set, change the thickness from 0.1 to 0.2. So it's a bigger, wider thing, and then set the spacing like one meter apart. So it give you like one right here and one right here. So that's just a matter of playing around. And the other thing associated with that is the keep. So this is going to keep 200 of those things on the screen at any time. And you can run that number up and down. I don't know what the maximum is before it starts bogging things down, but that's how that works. Oh, the other thing is, I said, yeah, position tolerance. So after it's moved 1/10 of a meter, it puts a bar on the screen. And then you have the angle tolerance, and I set it to 1 just because I didn't really care. That says as the vehicle is turning, say turning to the left or turning to the right, it says if it's turned this angle, then it will automatically put one of those markers on the screen. So all in all, that is a quick way. Say if your snowblower happened to be 1 meter wide, you can set this to 1 meter wide. And the only other problem right now is that this is actually putting it out on ODOM, which is the center of rotation of the vehicle, because that's what odometry gives you. And on Terry's case, he's going to have a snowblower out front here. So it seems like the quickest way to solve that is just write a node that says subscribe to ODOM, and then add the distance from your, basically add the wheelbase. So you take the distance from your back wheels out to your snowblower, add that onto it, and republish that and call it something like snowblower ODOM. So over here on the left, you can see under ODOM, it's subscribing to the topic ODOM, which is coming right out of the, in this case, it's coming out of Gazebo to tell you where you are. And you could just create another one of these and call it, say, snowblower ODOM as the display device, and then the topic, again, call it snowblower ODOM or whatever you created with that intermediate node. And I think that would give you the fact that as you drive around, it would be putting the marks out front here where your snowblower would actually be located. And whether it's a 4-wheel, Ackerman, or a 4-wheel skid steer or 2-wheel differential, it all works the same way. You've got the ODOMs telling you where your rotational center is. And I guess on, let's see, is that gonna, actually, I'm not sure. If you go to a 4-wheel differential drive, i.e. skid steer, I don't know if ODOM is going to be placed here or placed in the center of your vehicle. Maybe that's just a matter of, as you create it, you tell it where you want ODOM to be. But then, the ODOM message coming in from Gazebo is going to say, this is where you are. So that's might take a little playing around one way or the other to get that to come out. So let's see, did I have, if I back up to that other one, I was talking about it, how many it keeps on the screen. Let me go back to this one and see what I had there. And this isn't real obvious here because I stopped it fairly soon here. Back out like this. So I started at 0, 0 here. And as I was driving up, then I probably had this set to 1/10 of a meter or 2/10 of a meter. So as I drive along, it keeps putting these arrows on. It comes around here, and see, it keeps that many of them. And I think on mine, I increased that out to either like 500 arrows or something. But as it drives around, when the thing is coming up here on the left, it's coming back down like this. It gets to be right about here, and then the arrows over here start disappearing behind you. So it does 2 things. One, it shows you most of the arrows that are on there with the numbers I have right now. And then number 2, it's automatically deleting them. So by the time you drive back around to here and come to a stop right here, it's deleted up to about here. So you got an open path, so you can see as it's driving where it's putting the things. So that's just a few more things I noticed on that. So it's something you can play with. You don't have to write a bunch of extra code to make this work. You can just go put those in and say do it, and it does in fact work. So the next thing,
thank you.
Yeah, is there any more comments on that? I say it's kind of a hack. So, but it does show you, if you want to see the coverage you're doing, you can indeed see that. But I think you're going to find out when you go to drive this thing that you're probably going to want to have overlap between the pieces anyway.
Right.
You know, from my experience with snow blowers or a shovel, it turns out that, you know, no matter where you push the snow, you are going to have some that pushes off to the side. So you're probably going to end up, you know, overlapping your paths anyway by the time you're done. And you'd also mentioned that when you back up, you wanted to either raise your blade or raise the snowblower or turn it off. But I think, again, you know, from my experience with snowblowers, it doesn't really matter. You know, if you back up, whether the blade is down or up, I don't think it's going to matter. So, but that's just more than when you get something running that you can actually go out and play with the snow, then it'll become obvious real quick if you need to do things like that or not.
I was thinking of it more from the energy saving. If I'm going backwards 50% of the time, do I need to have the blower running?
Yeah. Okay. And you're right. It does depend on, you know, how long's your battery last and what you can make it do. So that's a very valid point there. Okay. So the next thing I wanted to talk about, let's see, I'm going to have to go back here to find that. When we were talking about keeping track of where you've been and staying on path, let's see, I have to do this now. This is part of that path that was the serpentine path. It just simply rotated 90 degrees here from what we just saw. But basically for the test, I basically started at 0 here on the left. So it's a 0, 0, and it drives down here to 10, 0. So it just creates a straight line there. And this big loop out here is actually made of 3 individual arcs. There's one arc right here to go from here. It actually should bend out like this. And then there's an arc that goes from here all the way around to here. That's a 4-meter diameter arc. And then again, there's a little arc here to connect those back together. And then from there, it just, again, draws a straight line back to this point where it starts into another small arc. And then if I go into that code that Juan and Matt were playing with, they put in a, I probably don't have a convenient way to pull that code up, but buried in that code, there was a comment that said, calculate the off path error. And everybody just assumed that meant how far is the base link of your vehicle off the path that we're trying to follow. So again, here's our path we're trying to follow. For the vehicle is sitting here like this, and base link is in the back, and the front of the vehicle is here, and then your look ahead is out here somewhere. I think it was something about, I was trying to calculate how far the look ahead point is off the line that's drawn by your vehicle. So I don't think it's actually telling you how close your vehicle is to the line. It's just it's an internal calculation saying our look ahead is out here. Because when you get down here and start going around the circle, you know, your vehicle can be right here, but the look ahead is out here. And that's definitely, you know, showing you a big error there. So I think what you need to do is go through the code and find the point that says measure base link to the line and publish that. So if I back up here to this one, this is what you give, you plot that out. So my vehicle wasn't pointed straight on the line because I had come around, and when it stops, I stopped pointing in the right direction. So when I first started up, it's got this weird thing here. And then this right here is the straight line going to the right on that picture that I just had. So it's trying to align itself, and it has a little bit of overshoot. And then once it's on a straight line, it's doing a pretty good job of tracking it. And likewise, when we come back out of the big loop, here again, the straight line is doing a good job. So if we're on here, we're on the straight line going to the right. We go into that little arc. Here's the indication from the little arc, and then we change direction so it jumps up here. And this is the big 4-meter diameter arc that's showing us here. And when it changes direction, it goes back into the little arc, and it shows this and corrects, and it goes back to drawing a straight line again. But as I got to looking at this, you know, number one, I couldn't figure out why does it have all these spikes out here. And that's what led me to believe that this is not shown as base link. It's something about the off, or what do you call it, the look ahead pointer. And I think each time each one of these spikes is that segment that I just showed. Again, here we'll go back to here. And this is the one that has a 1-meter segment. So this picture doesn't actually match what I just showed you. So when I ran it, I I increased it. So instead of having 1 meter between these segments, so you can see a point there, a point there, a point there, one there, one there. So you can see it's kind of choppy as it goes around. So I'm guessing that if you would run it against this, you're going to get 1, 2, 3, 4, 5, 6. You're going to get about 10 or 12. I think you're getting about 10 or 12 of these things. And I had increased mine to the point where I'm saying every 0.2 meters. And that, number one, it smooths out the curve a lot. And if you just do some quick calculations, I decided there's probably 30 to 40 segments around that big loop. And by looking at this, I didn't count these, but that might be 30 to 40 showing up there. So I think, number one, I think we're just simply looking at the wrong stuff here. And then secondly, this indicates that I think this is, anytime it switches segments, this is bouncing back and forth. If you look at this one right here, you can see it comes up. You can see there's a background sine wave here as it's trying to track going around the circle. And it could be by tuning values, you can get rid of that. But these little spikes shouldn't be on there at all if we were looking at the right thing, because the vehicle can't move back and forth that fast. So that's why I think it's something to do with the that look ahead pointer, and that's way out in front of the vehicle as it's moving back and forth. So the point is, I had found this, and back on here, let's do I need to say anything more about this? This is putting out what was called off path error. So if I come back here to this one, okay, what did that do? It so of course it opened that in another tab just to make me mad here. Here, let's don't find it there. Let's go back to random. And this one. Okay, that comes up. So something else Matt had done, he found this cute little text display that it's a plugin for RVIZ. So you can plop it on the screen and then subscribe to whatever topic you want. So you can put out numbers and they show up on the screen here. And his point was, as he drives around here, it would the pure pursuit would calculate what it thinks is the off path error. It would publish that by, I can't remember what the name was. Then he had a little Python node that would subscribe to that and just republish it. So it basically shows up on the screen here. So if I'd gone further down this path, I could figure out how to get that plug-in to work, and then get the things tied together so I could actually watch these numbers change as I'm driving around. And even watching this, if you go pull up his video on this, you'll see that part of the time it'll be up like this, and it's got those same spikes there, and when it turns goes the other direction, it's got the same spikes going down. So it's basically text on top of a little oscilloscope display here. Can I do this? So you can see in the background there's a few little bumps right there, and then right here you can see big spikes coming out as it's going into the end of the curve there. So the point was, yes, it would be very handy to have. And I was saying before, it couldn't be right because I was nowhere off by a quarter of a meter. So down here, this grid is 1 meter, and up here you can see his was off by like a meter or so. And I can't set my parameters, make mine act as bad as his did. So I think there might have been something funny between the stage and the way things were scaled is why it was off so far. And again, I think this is showing, it's not showing where the vehicle actually is. I think it's showing that, I think it's showing either the look ahead marker or actually it's not. So anyway, I think if somebody plays with that, we could figure out, better ways to make that work. And so I can think that's all I had to say about that. Any questions on it before we go to the next thing?
Very interesting.
Okay, so let me do stop sharing. Okay, and then the other thing was I'm back, again, back to the point I'm trying to decide, how do I want to set up my, this might screw up, my background might screw this up. But anyway, this is the board that was on my Sammy 2 robot. That was just a ST Micro eval board. It's got a fairly big processor, and it's got a lot of IO pins. So there's dual rows of pins here. So it's got like 100 pins on this board. So I can do quite a bit of stuff with that. And then it turns out when Juan found out you can't buy that board anymore, he looked on either Amazon or eBay and came up with this board. And here, as a size comparison, See, it's basically the same chip on the little board, but it doesn't have as much junk on it. So it doesn't have the big board has some kind of fancy audio processor and some other, it's got lots of LEDs and push buttons on it. And the little board is basically so it's got the chip here, and then it does have an SD flash card socket here. And then it does have, there's some kind of like a serial flash memory, just some external thing stuck on there. But other than that, it doesn't have a lot of extra stuff on this board to get in the way. It still has dual row header here and down here, and it has probably almost, it might have the same number of pins or just a few less pins on the thing. And this one was originally, I think, $20, but you can't buy it anymore. And this one I think came out, or I think it was like $11 to $15 or something. But it's got the same processor. You can buy it with the same processor or processor with half the memory for, you know, $5 cheaper or something. So that was something that Juan was playing with, and I did get that to work. And then the other thing is the blue pill board, which is just a smaller. So again, comparing the size on these, see, it's a much smaller board, and the processor has much fewer pins on it. But theoretically, if you play hard enough, you can load a Arduino bootloader on this and get it to work. You know, so I can fire up the Arduino IDE, write my code, and say download, or I think they call it upload, and it should load the code and start running. So if I could get that to work, that might be beneficial, just so, you know, all the different development systems are the same. They're all using the same Arduino IDE. And all three of these chips, they're all ST microchips. This is actually like a Cortex F1 or M1. It's an older processor, but it still seems to have all the peripherals that I would want on the thing, and it's still quite fast and has enough RAM and ROM to do the job. So I might switch over to something like this, and as opposed to, and the main reason I want to go with the ST micro parts is because I can do up to 4 channels of quadrature decode, because it's got hardware built in to do that. That's my main reason to stick with these, and part of it is because that board was used on my SAMI too, so I've got code written that knows how to talk to those peripherals, and it just be a matter of hacking all the stuff together. Another issue I had was, you know, again, so this board, this happens to be the blue pill board, it's got pins soldered in the bottom. So I was trying to decide, do I want to stick that into a proto board and just plug in wires, or do I want to get a piece of perf board and solder down some sockets? I had a perf board laying in the way here, but anyway, just solder some sockets down on a perf board and put connectors. Do I want to do it that way? Or another option would be to use these to really get a quick hack. You know, you got these jumpers that are they call them the DuPont jumpers, and it's just got, you know, you got the little connector on the end, you can plug them onto the pins. Well, I could just take them and plug those right onto, just to experiment, just plug them right onto these pins, and then just plug them into whatever I want at the other end. I wouldn't do that, you know, in real life. Because they need to have a board flopping around all those wires there, and they're going to fall off on you. So you don't want to do that. And I don't have a good example, because I took this big board and took a big piece of perf board and then soldered down, you know, connectors for those two, and just plug this onto the perf board. And then I had extra room. I just put connectors and stuff and just wired point to point to make all that stuff work. So it's back to the point. I'm just trying to decide, you know, how would I want to do this, and, you know, what's the quickest way. But I know the quickest way is not going to be the most secure in the long run. So that's just more stuff to think about there. Another thing that comes up there, I keep thinking, well, how could this be more universal? Well, you could put, you know, solder or plug your board into a piece of perf board, and then have standardized connectors, which means now all your peripherals you want, or your external devices you want to hook up, you know, you have to make those fit that type of connectors. So you might have like 4-pin connectors that would have, say, +5 ground and 2 signal leads on, and depending what you're hooking up to, so the quadrature, those pins would have to go. So 4 of your connectors could go to quadrature decode pins, which could also be used as timers. That can also be used as standard IO or whatever. So that might be another way to go on that. I think right now the Pitman motors that are on the back of my new robot, they had I think it was a 6-pin connector on there. It was like a single inline connector, so it had +5 and ground, and phase A and phase B, and then the two motor leads also went through there. And somewhere along the line, I cut the leads on the motor leads, but I could cut all those wires off and put them onto the, get the little DuPont connectors and just have those so they would plug in. So I could standardize on that. I don't know if that makes sense or not. So just more things to think about there. More things to
I would
waste.
think separating the motor power from the encoder would be a good idea.
It probably would, yeah. And technically coming off the motor, it's got like the two power leads are twisted, and then the ones coming off the encoder are 4 separate leads. So they're technically not together at all. It's just when they ran through the connector. That's the way they decided to do that. And on small motors, it's not as big an issue. You get to big motors that it starts to become more of an issue. So yeah, that could be a problem. So other than that, back to the blue pill board. It turns out there is a bootloader you can load on this thing, and I think I have successfully treated this like an Arduino. So you put that bootloader on, and then you can say upload the code to this board, and it will do it, through the USB connector that's on here. And then also when you load that bootloader, then this USB becomes like the debug interface on an Arduino. So you can say print, and it will come out that and show up on your screen. So that'd be one thing. It would be good to figure out how to get that working and make sure it's going to work, and then track down the various libraries. Some guy in the Homebrew Robotics group has created the quadrature decode function that will run on the blue pill board, and he may or may not have treated it like an Arduino. I'm not sure. I don't remember. And
Yeah, I know I'm thinking about how to use 2 serial outputs from my Itsy Bitsy. The one of them is for the is on the USB. That's serial 0. But I want to be able to have a communications to the Raspberry Pi, and I don't want to do that through the USB.
What was the deal on the Raspberry Pi? Which version of Raspberry Pi do you have?
3B,
4?
3B.
Okay, because somewhere along the line, on the version 2, they brought up the 2 UART pins to the pins on the edge, but then when they moved on to the 4, was it 4 or 3? Does the 3 have the Wi-Fi built in, or the, yeah?
3 has Wi-Fi built in, but it also has transmit and receive.
Okay, now the problem is when they added that chip for the Wi-Fi, it's got the Wi-Fi and it's got the Bluetooth. The Bluetooth uses serial, and I believe the Bluetooth is connected to those 2 pins on the edge. So possibly just turning off the Bluetooth, now those pins will be available on the Raspberry Pi. I don't remember the all the details behind that. So you might want to track that down when you go to do that, look and see what they say about that.
Okay.
And it could be the Raspberry Pi 4. I thought they put a newer, bigger chip on that. And it could be you have more multi-function pins, so you might have more than one UART available. But I don't remember right offhand. And since if you don't have a 4 already, and I'm sure they're still real expensive at this point, so don't hold your breath waiting for that.
No, I don't have a 4, and it's got UART transmit and UART receive for GPIO pins 15 and 16.
Are you looking at it online? What's its price?
No, I've got a printout of the Raspberry Pi 3 Model B J8 header.
And usually if you go looking for Raspberry Pi 4s, they'll just say simply say they're out of stock. Then you can go out on like Amazon and eBay, and people charge you, $100 to $200 is what they want for them, because apparently somebody's willing to pay that. But now on the Raspberry Pi 4, I think if you look at the GPIO pins, it may just define them as the standard ones, but if you dig harder, it'll say, oh, well, these pins down here, you can also, I think there's maybe 2 I2C channels on the thing. And I was thinking there might be up to 4 UARTs. Whether they bring them all out, I don't remember. But it's a matter of, setting the thing up and saying, I want to define these as, say, a UART as opposed to IO or something. So that's just something you might run into on that.
Okay.
And the other option is if your itsy bitsy board that's got a USB on that,
Yes, it does.
because you can plug a USB cable into that and plug that into Raspberry Pi and talk to it that way too. So that works out. It basically works the same way. It's just you've got, you know, just hook the cable between. That also makes it easier when you go to program it because it's already connected. If you're able to program it through your Raspberry Pi, which Al knows how to do all that stuff. He was playing with that platform IO, or you know, you could probably just do a secure shell. Or you could take your hex file and download it to your Raspberry Pi, and then there's like a command line. I think there's a command line Raspberry Pi function that says program this hex file into something. So that, again, there's various ways to do that. Typically, I
Right.
just unplug the cable and plug it in something else and program it, and then put it back the way it was, if I need to do that. So
Well, I'm trying to get away from having to do that. So
yeah,
Pick the editor you like, and more than likely there's a plugin to talk to it. If happy to show you what I've done with VS Code Platform IO.
you know, my thought is to start with just do whatever's simplest, and then, you know, put it on the back burner and say later I'm going to have it so I can automatically program everything in circuit.
Jeff, right there. I mean, many a times I've gone back to the Arduino IDE and like, I'm just going to get it to work here. And
Yeah. And I will have to bring up the story of Cray, where they're building supercomputers, which is basically you got a box the size of a refrigerator, and you have, I think it had 32, 8, 24, 8 times 3, 24 nodes inside of this box the size of a refrigerator, and a node was a Linux processor. And for each processor, you had a PIC processor that did things like turn the power on and off and measured voltage and all this kind of stuff. And all the little power modules had little PIC processors everywhere. So you get a big system and you end up with, say, 40,000 microcontrollers in this box. They said, well, next time around, let's make everything in circuit programmable. So they went to a lot of work where you can sit at a workstation at the side of the room and say, I want to update all the controller processors on, say, I want to update 40,000 of those. And it goes out and broadcasts in parallel, says, here, reprogram these, and it would go through and do that. So that becomes real handy when you can do that. Otherwise, they'd have to, you know, open the cabinet, pull one of the boards out, and then get the little the PIC microchip programmer. So you hook it up to your laptop, plug it into the little connector on the board, and program the four PIC processors that do that. Now, if you wanted to do the power supplies, I think you had to pull those out and program them some other way. So it could get to be a real pain to do any of that stuff, because, you know, it's like anything else. You say, oh, we made this change. Let's go program this entire room full of devices. They tear them all apart, reprogram. Somebody says, oh, damn, we should have put a 3 instead of a 2 in there. And they say, oh, damn, now we can tear it all apart again and redo it all. So yeah, that becomes extremely handy to be able to program in circuit like that. Oh, the other thing, you were talking about using UART to connect stuff together. And I'm back to the point where I'm gonna have to make a new remote control. And I was thinking on my Sammy 2, I ended up not using the Adafruit board. I had that board that was called like, they called it LoRa M0 feather board. So it had a processor and a LoRa chip on the board that was in a package, you know, basically in a package like this. And it turns out that I wanted to have CAN because I was trying to duplicate the one our industrial one at work. So I couldn't get that chip to do it. The M0 processor does not have the CAN peripheral built in. So I bought a Teensy 3.2 and a feather adapter, and I bought a new feather board that's just the LoRa radio. I stacked all those together and put a CAN peripheral or a CAN transceiver on it. And I was able to get that one to talk with CAN. But this new one, I don't care if it has CAN or not. So I'll take the extra board that I was going to use for that and just program it to be my remote control, and then just have the 2 UART pins somewhere on that board, because I think that's got lots of extra UARTs on it. And that way I'll just have it talk from that board with UART to say one of these boards, you know, that would be the way to do it. So but that little board from Adafruit, I'll have to supply it with power, I'll have to have the 2 UART pins and then 1 or 2 signals coming out to control my e-stop circuit. So that's something else that I was just thinking about using UARTs to talk back and forth between things. And if I decide for some reason to have more than one low level controller, I decided to connect all those together with UARTs too, because I prefer UARTs over I2C, because I2C is a pain to get it to, you know, you got to define your own protocols and you got to get it to work, and hopefully it does continue to work. So you know, I'm old school. I like to go to UART, where you just simply slam this out and the other end will read it, and everybody's happy. So
And it's bi-directional. That's the one thing I don't like about SPI, which is there's a master and slave.
yeah. And actually on I2C, you can make masters, you can make multi-master or master slave on that too. But so there's lots of things you can do, but I just prefer the UART, where, you know, it's definitely point to point, and you can do a little extra screwing around. You can get it to do like multi-master on a single pair of wires, but that's again, that's just more screwing around that I don't want to have to do if I don't really need to do that. I don't intend to do that at this point. So that's all I got on that, I guess. Anything else before we cut it off? Okay, I'll point
Sounds
out
good to me.
my front yard's full of snow again after it warmed up and most of the snow had gone, and then boom, we got 12 inches of snow. So it's gonna be a while before I go out and drive around with my stuff. So that's all I had to say about that.